Okay, I will add him on Hangouts directly. Okay, so just to quickly catch up from yesterday, so we went through the overview of AWS Essentials, and there is a small change here. Actually, I wanted to make sure you all aware of it. Yesterday, I switched the lab. Actually, the first lab supposed to be Introduction to AWS Lambda, but after we learned the AWS Essentials, but I actually used the DynamoDB exercise. Doesn't matter actually. Initial first two labs basically are more like very basic, and there is no problem with any order. But generally, it's better to do once you learn AWS Essentials. Try to do something with AWS Lambda, which is more like a more latest feature of AWS services. So that will give some idea, and which will also be used in our some of our big data analytics particular assignments as well. Okay, so but since we did already DynamoDB, today we will focus on the lab that for AWS Lambda when we come to the lab section. But mainly the first two modules, if you see, it's really to understand the essentials, which is really fundamental stuff. Without these fundamentals, it's very difficult to understand this course. So I'm trying to make those two as the first two things. The first one, AWS Essentials, we got some overview yesterday, and I'm hoping you all familiar with it now. And now, similarly, today we have to make the complete overview of big data and Hadoop essentials, which is really essential, because without some of this terminology that what we are going to talk today, when we go deep dive into some of the later sessions, it's very difficult to correlate what you're learning. Okay, so please stay focused on this today. I will try to cover this quickly. It's already like 8:40 now, so I'll try to stick with our time. By 10:30 we should be able to cover it. And again, the last half hour we'll try to do the lab, and even if it needs a little extra time, that you can continue, or you can take separately. But I generally prefer to finish the lab in the class itself. That way, if you have any issues, I can help right there. But yesterday we couldn't get that much time, so I asked you to do at home. So I'm hoping you all covered it. Let me know in the next 5 minutes. We can at least see if any specific issues, if anybody faced any issues, connecting to, opening account and first time, because you're opening the account first time and using it first time. So let me know if any issues, okay, or any questions from yesterday's session that you need some additional clarification or anything. So meanwhile, let me check with Om. So Om, you're able to join, Om? Yeah, I didn't see him. Nagaraj, I'm not seeing you also.
No. If you see the TM Kishi, that's me.
Oh,
I
okay,
mean,
okay.
like,
The name
I have
is
two profiles. Yeah.
got it.
I
Okay,
keep getting dropped with the Nagaraj Sota, so I joined with this TM.
no problem. Yeah. Okay. All right. So yeah, hopefully will be able to join, but I thought this next 5 minutes, if we can use some time to discuss any open questions, meanwhile he can join, but otherwise we'll get started. Okay, no worries. I think it looks like he's stuck on the road, so hopefully he'll come and catch up. No problem. There will be audio, video anyway, so recording, so nothing to worry. Okay, so if silence, that means I'm not expecting any problems for any of you on the lab, yesterday's lab. Okay, so just to quickly catch up, this is what we covered in the session one overview of. Can everyone see my screen? Can anyone confirm? I shared my screen, so just want to make sure you're seeing my presentation here.
Yeah, we
Yeah,
can see it.
I can see your screen, sir.
Very good. Okay. All right. So okay. So this is what we covered. We learned about how the traditional infrastructure versus Amazon Web Services, and we discussed all these details. So I'll just quickly pass through on this, see if any questions come out for you. Advantages and the benefits of AWS cloud computing, and the foundation infrastructure, foundation services, and platform services applications. General, these are all like for general terminology, and what is the landscape of overall AWS services. There are so many services out there, but we try to show them as in various categories, and discuss about some of these basic things that we will be using. Okay, and we talked about this responsibility also. The AWS infrastructure comes with a shared responsibility model, which is something, though it is like a managed service, so there are something still our responsibility, at least the user data part. Okay, so let me quickly jump on to the next session. So this is about the big data and Hadoop essentials. Okay, so here, so a lot of people, I mean, I know most of you might already know, because we've been talking about this big data everywhere nowadays. So in case if you are not familiar, just try to remember these three keywords: volume, variety, and velocity. These three keywords will define the characteristics of big data. Okay, so the data is always there, but if anything to be called as big data, at least it should have more than one of these three characteristics. That means at least it should have two characteristics, two or three characteristics of these three. That means it is volume, like beyond limits that traditional system cannot maintain, or the variety of the data. Variety means like the type of data. It may not be structured data. It could be semi-structured or unstructured data, or it could be the velocity, the speed. Uh, Speed means basically like a streaming type of, like immediate real-time streaming type of data. So if any of such needs comes for your business needs, if you see there is a need for huge volume, or multiple variety data sets, and velocity, any of these three, at least two, you should immediately consider that scenario is as a big data scenario, and you should look at your solution to be big data solution. Okay, so here is a very a nice quote from Google CEO. It was, every 2 days now we create as much information as we did from the dawn of civilization up until 2003. Imagine that, until 2003, which is just like a few years, like 10-15 years before, how much data we accumulated in this entire world from the starting of civilization. Imagine that. And that much of data, every 2 days now we are creating as much as that. Unimaginable, that much data growing. Okay, so I mean, these are some statistics. I think this is a little old information, but still it is true. It may be much beyond this. So on every 2 days, we are generating like more than 168 million emails, 695,000 Facebook updates, and Google search queries like around 700. These are all like little old. Don't I'm sure these are all like already into multi-millions, no doubt. Okay. So this slide explains how the over the period the data evolved, like the systems changed, how to manage the data in the traditional systems, right? The size of databases is keep on going, the data size going. And if you see, um, we used to have unstructured data, flat files, spreadsheets, then database management started in like all RDBMS type of databases came. Then multidimensional cubes like you know Cognos cubes or S-base cubes, and a lot of multidimensional cube type of technologies came in later on. And the data visualization and visual analytics is now totally dominating the BI market now in the big data analytics. So if you see how it was managed initially, they used to have like a reference data sets, and then like some Excels came, and then Access and Xbase, then SQL Server, Oracle DB, that type of things, and then ClickView, Power Pivot, and some of these new tools started. Okay, so again, you just see that size of data growth here happening from megabytes to gigabytes, gigabytes to terabytes, terabytes to petabytes. It's growing like exponential. Okay, so that's the type of data growth happening. That's why, I mean, if you ask why anybody would care about big data or big data solutions or big data analytics nowadays, this is the main reason. It is growing like that, so there is no option. It's not a choice anymore. All right. Oh, can you excuse me? I will take this call. I need to take 1 second. Okay, sorry about that. Okay, so here, if you see the market here, right, the big data market, pretty much like it's every year it's actually doubling, but this is something that people assume that a lot of the statistics here you see are like a year old at least, and they are every year getting doubled. What type of data? If you see here, so many like news feeds and music streamings, new ads posted on the Skype type of information. You'll see so many things here, like search queries, email sent, so many blogs posted, new videos posted, a lot of content, like data becoming not anymore just like rows and columns anymore. It's like a lot of videos and audios, a lot of content management also coming into picture. So like a huge data sets. Okay, this is a quick roadmap of how big data evolved over the period. Okay, initially this was started from Google, because initially the data, this type of data is mostly all other companies like regular banking or telecom or pharma or any of such companies, they don't have such need to deal with all these file systems like this, because mostly they are either using some mainframes or databases, so which is enough for them to manage their systems, and they never really worried about any special needs to work with log files and file system based processing. So but Google was dealing with search engine, and which is like all the basically it's all about text, right? So lot of text searches happening, and the kind of data they collect, it is not in a proper format. It's not like structured, clear, you know, in a specific format. So they have to deal with a lot of unstructured data to analyze that. So there was no solution. So that's why they started, like, first of all, the size of data is so much, and the type of data is so much different than regular data structures. So they were struggling with that, and they come up with something called Google File System, and they created map reduce algorithms. And initially it's basically crawling and indexing, basically the web logs. And then basically over the period it became like they created something called map reduce algorithm, and that's when actually Hadoop born, in the initial stages. And then Yahoo put the Hadoop into more like enterprise use. Initially it's only being used by like couple of companies like Google and some technology companies, but then Yahoo made it more like enterprise use, and then open source community adapted, and from then it became like a more of a Apache foundation. All the framework, whatever the source code they build, all the libraries and frameworks they build, it's all under Apache foundation as part of open source community. And from there, all the distribution tools started coming: Cloudera, Hortonworks, Azure, now Amazon EMR. So all these are like the wrappers on top of Apache foundation, basically. Okay, so this is the brief history. If you see from the time perspective, like this whole thing started in something around early 2000s, right? So but now if you see here, we are in the last 10 years or 10 at least 15 years, so much until 2008 or maybe 10, I would say, not that much of things happened, right? So sorry, one second, I keep getting a lot of calls. Okay, so yeah, until though it was started like early 2000, 2002, but until 2008 or 10, at least for me, it was first I started my project, at least on this, is 2012, into 2012. But it was just in the early stage. 2010 onwards, I think it became more enterprise type of solution. Hadoop solution started. Some people started using. But in the financial sector, at least 2012 is the time. 2011, maybe 2012. Actually, we are one of the first company to adopt also Hadoop technologies when I was with Bank of America Merrill Lynch. Okay. So these are a lot of players in the big data right now in the market. If you see the landscape, this is again, I put this long back like 2014, but there are so many players. Imagine in 2014 itself, that many players are there for big data. In the last couple of years, so many new players added. This is like one of the hot market area. So many people are getting into this landscape, and it may not be, everyone is not specialized in every area. Some people may be in analytics area, some people in operational area, some people in the database area, some people on focusing on the apps, some people are on the infrastructure side. So every company and every product is focused, not everything like a package, but there are so many niche players now, new players. All right, so having said that, now what happened to the traditional large scale distributed systems, so which are all happening based on computation, right? So now we are talking about cloud, big data strategy and all this. So what happened to all traditional large scale distributed systems? If you just think of that, distributed systems are always there, but programming, so mainly if you see why there is a need to shift our gears and move towards new terminology or new technology, and why the traditional distributed systems are not uh, enough to meet our needs, right? First of all, they're very complex. The systems, the traditional distributed systems, are very complex, and specific to, if you talk about data exchange, the just keeping the data in sync, like keeping it synchronized, uh, it is a big painful job. So, and it needs like finite bandwidth is only, it has a limited capacities, like storage wise, capacity wise of this infrastructure wise. It's still difficult to deal with the partial failures of the system. So basically, the systems are not, all the traditional systems are designed for some level of data volumes and data variety and data velocity, but they're not really designed to meet the needs of big data requirements. So it has to be like, you have to take a new approach, right? You cannot just depend on what was designed all the years. The systems for different needs cannot satisfy the big data needs. So the new approach started, basically the requirements, basically what all the requirements, if you look at why we need a new approach: partial failure support, data recoverability, component recovery, consistency, scalability. All these are like standard architectural terminology, but these are all always there. But the same requirements there, but in the context of limited volume, limited data types, limited the frequency of data synchronization. But those limits are, once we cross the limits, and big data has no boundaries now, so it could go to any extent with the way that you see the data getting captured now. So that's why the new approach required. So if you see here, now we are just getting into some basic concepts here, because why it is important to understand these things. Without fundamental understanding of why big data, why Hadoop, and all some of this stuff, you may not be able to digest any solution you create. Okay, so you know the requirements, but what happened to your core concepts, right? So if you see this pyramid, this is very, very important. Pay attention to this. The core Hadoop concept, this is one of the fundamental concept. Applications are written in high level code. Okay, developers need not worry about network programming, temporal dependencies, or low level infrastructure things. That's application is always at the higher level, right? You don't really care about what is network level, some of the system level programming. And data is spread among machines in advance. What that means, data is replicated multiple times on the system, and for the reason for that, you need to have a high availability and high reliability. Okay, so that's why it is spread across multiple machines. We call them data nodes. And most important shift in this paradigm compared to distributed computing, that is, computation happens where data is stored. This is what I think I mentioned this already in my orientation if you attended. This is one of the biggest difference. It's not that earlier all the traditional systems, computation happens like you write some function, like do some x plus y equal to g, whatever, right? And that happens, and whatever data it needs, it gets the data from database or the network, and it will do the calculation, that computation, and show you the result on the UI. That's how it was working all the traditional systems earlier. Now it's totally different. When the data size is limited, your database is in maybe up to gigabytes or terabytes, it is okay, because your network bandwidth can support to move the data across the network, and it is still manageable. But once you are looking at the petabytes and zettabytes, all the kind of a mountain of data, it doesn't make any sense to move that much of data over the network for your computation. So the thinking itself totally changed here. So you take your computation to the data. Instead of moving a big mountain, you go to the mountain and you make the you get your work done there. So that's the concept change. Okay, so that's what it says. Rather than getting data to the computation process, we take the computation process to the data. That's the biggest change in the way how traditional systems was working, and the new Hadoop systems are working. All right, so this is some funny thing here. Who's Hadoop other than looking like this? Some looks funny, but some people say it is important to know background of some of these things, keywords, and why these things came in the first place. Anyone can guess this why it is? This is
Uh,
a yeah,
he named Hadoop. I mean, he kept the elephant because his son used to have an elephant toy.
right, exactly. Yeah, the creator of this Hadoop, who actually he just came up with the word Hadoop, and the name of his son's toy, which is elephant, and that's why he just named it as Hadoop, and the logo itself became elephant. So, but now it's ruling the world, right? So here, this is where you'll see some of the we are trying to understand some of the underlying things for Hadoop framework. So it's a software framework, right? It supports very large scale data intensive processing, and it's free to use because it's open source. And when I say open source, Hadoop is open source from the Apache Foundation libraries. But nobody, at least most of the big organizations, they don't directly use Apache Foundation as it is. The libraries, though it's available, there is a reason why they don't directly use, because a lot of this thing needs some technical background to people understand that existing libraries and use them effectively. So all these um, other companies like Cloudera, Hortonworks, MapR, Azure, and a lot, yeah, Amazon. So all these guys came out with a nice tools around this framework, and they made it so easy for anyone can learn and quickly uh, build their Hadoop environment and make use of the system. So that's why all these. I mean, it's not only convenience or easiness. Mainly, whenever you need to, suppose you need to upgrade something or you need to change something, Apache, it's open source, right? Somebody might make some changes, and they improve something. So when you need to bring some of the things into your system, you have to do, if you start using the underlying libraries, like it's like a hard coding things, right? So you have to rework a lot of stuff. So when you're covered with a product like this, the product will take care of it. Like you don't just, they don't release every small patch. Once in a while you'll do upgrades, but it is not like for every small change you'll have impact. You should not worry about that. Anyway, so underlying basically the two important terminology that you have to remember: HDFS, MapReduce. This will be, you'll be hearing this a lot. HDFS, MapReduce. The reason for that, these are the core components of Hadoop. Okay, underlying, it's a file system that's called Hadoop distributed file system, very large distributed file system. And MapReduce is basically parallel programming model to process large scale data. Okay, these two fundamental components will be the core components for Hadoop. So now what will happen, like a set of machines running HDFS and MapReduce, this is called Hadoop cluster. So usually the biggest difference in the Hadoop systems and the traditional systems, we used to buy like big servers, like huge capacity servers, like one big system maybe, or one big mainframe, or like suppose Netasia or Teradata. So you take a lot of these big machines, heavy duty machines. No such things in Hadoop. Hadoop actually use cheap hardware, a small cheap hardware nodes, but number of nodes as a cluster. The reason for that, it is supposed to be hardware, inexpensive hardware, like it could be even your home laptop, right? If you combine like 100 laptops, it could be like a one big HDFS environment. You could create huge um, a cluster and make it as like a enterprise level application. Okay, so the reason for that, why it is okay to use cheap hardware and doesn't need to be expensive hardware. The failure is not anymore a problem. If something is failed, one node is failed, or some of the nodes are failed, you don't need to worry too much about that, because the architecture wise, adding nodes, removing nodes is like just like in a split second basically. Okay, so it doesn't affect anything what data you're storing on the system. Earlier, right, if my one big server, if I keep and I keep a lot of data saved on that, and suddenly that system got crashed, that means I lost all my data. So that was the biggest danger threat, right? So that's why people worry having a cheap hardware or something, that they use heavy high capacity servers. But now Hadoop changed that whole thing. You can use very low end hardware, because as long as you have all the clustered setup, even if one is gone or some other things gone, your data is not lost. It never lost, because it is actually replicating to various multiple nodes, and same data is available on every node almost. Okay, there is a lot of redundancy. Redundancy is one of the feature. Don't think that is as a negative thing. Okay, because that's how you get the high availability. So that's some of the basic things there. And yeah, there are a lot of projects built around the core Hadoop ecosystem. Things like HBase, Hive, Impala, Scoop, Spark. So all these projects is like you can consider them as like tools for you to work in a Hadoop environment. You need to be aware of all these tools. In one or the other way, you will be using them throughout our exercise also. Okay, so those are the things we are going to learn, how to use them, how to why not only using, like you should know why are you using them, right, and which tool should be used in what scenario. So a lot of the stuff will be covered in our course. But the first thing first, you need to be uh, registering all these keywords into your mind, um, at least to have context of what we're talking. Okay, so I'm going to go a little more deep into the technicalities here, how the HDFS file system works. Okay, I mean, it may be a little bit boring here for a few slides, because we are going into deep technical information, but understanding this is very important. Only this particular session, the second module like this, it will be very deep, but otherwise everything else will be, you'll be playing with the system and doing the hands-on work. But this one is fundamental. Without these fundamentals, you may not be successful in interviews, or and also like you may not be a successful Hadoop developer if you can't understand some of these basics. Okay, so it's very important. So even after the session, I would prefer to take some there are a lot of documents, and I provided all the references already, so you could actually go through some of these fundamentals again. But I would suggest stay focused a little bit here, what I explain, because I try to summarize some of this stuff. Okay, so if you talk about basic concepts here, based on the Google GFS, which is a Google file system, and it sits on the native file system, provides redundant storage for massive amounts of data using cheap, unreliable computers, like I mentioned earlier, right? Files in HDFS are write once. No random writes to files are allowed, but append supports. Okay, so what that means, understand that statement. In HDFS, the concept is always write once. You don't touch, like in a traditional database, you write a record, you update record, you delete a record, you do a lot of stuff. You play with the data, you manipulate the data so much, right? But in HDFS, consider like it is your storage place. Once you put it, you put it. You don't need to really change anything. If you want to put one more thing, yeah, you put it. Let's say you have some update, yeah, put another. You keep on appending it. You don't need to, because why we used to have traditional systems or Oracle database or any other databases earlier, you are updating or overwriting or deleting and all that stuff. Storage is one of the big constraint, and you got to be careful about how you use your data, and also like even in the traditional systems, having history is very important. Suppose if you take some of the data warehouse systems, people want to maintain history and they don't delete. Once it comes, they maintain the history. So you think of this way, HDF is like a big data warehouse, and that's why people call it like a data lake. So you never need to really lose your information. You keep on adding, because it's like a big storage area, and you keep on adding it right once. Okay, nothing to worry about delete and update and all that, until unless this is like really something that you have to really delete for some legal or compliance reasons. That still things can be possible. You could delete some files and all that, but not like an individual record or a particular column like that. Okay, that's the biggest difference. HDFS is optimized for large streaming read of files. So basically, the HDFS, as I told, it is built for to handle the processing of large streaming feeds of files. So it can easily handle any regular things. Yeah, look at this. Actually, I want to mention this one. Files are split into blocks automatically. That's one of the important thing of HDFS. When you put a file, some data onto HDFS platform, it's automatically split into blocks. And usually like 64 MB or one. Right now, I mean, initially it used to be like 64 MB, but now most of the systems are 128 MB. You could configure, actually you could change them, but by default I think most of them now 128. And if you see here how it maintained, the memory node attached to a pool, everything will have a signature, and the memory block requested by user, and this is signature. So this is the underlying. If you see how actual the each block level, how it stores the data. Okay, it maintains a signature for the memory block itself. Okay, which memory block requested by which user, and it will maintain a signature for that, and which memory node attached to a pool, so it maintain a signature at that level. So that's why it can the reason why it needs to maintain the signature there, it has to keep track what is being stored by whom and what is being accessed by whom. Then only it can manage the whole data management. Okay, so here is a very a nice picture that can give you a good understanding of how this whole mechanics, like how this data being really managed. Okay, so when we talk about Hadoop, we talked about two things, HDFS and MapReduce, right? So we are going to get into MapReduce reasons why MapReduce is an important component, and if you understand this example, you'll get to know better on that. Okay, so if file comes, let's say you got some data piece and which has 4 different parts, 1 2 3 4. Okay, basically it's splitting. For it doesn't come like a 1 2 3 4. When it comes like one big block of data, right? And HDFS understands, and it has a built-in mechanism that can split into multiple chunks, multiple blocks, and the blocks will go. And again, remember the original architecture wise, there's something called name node. There will be one name node which will is like a manager. Basically, it will keep track of all the activity happening by all the data nodes. Okay, mostly you will have one name node, but you will have a lot of data nodes. When you say you have a lot of thousands of nodes of clusters, you are keep adding a lot of data nodes, not the name nodes. Name node is like a metadata, so which is, it doesn't really hold the real data. It holds the metadata. It's about the data about data. That means what data is going to what data node, and what data being accessed by which user. All that type of information it's tracking. It's basically a tracker, name node. That's how it can coordinate And because when you run a query quickly, right, you get the data, you don't know where it is getting the data from, because as I told earlier, the data is there in all the data nodes, replicated. That's what you'll see here. Let's say I got 1 2 3 4, right? So what it's doing, it's sending 1 to the data node, first data node, and here the 1 is not just sitting there, 1 is also replicating to in all other areas, and 2 is going to the second data node, but it's not sitting there, it is also replicating to other data nodes. 3 is going, but 3 is also replicating to other data nodes. 4 is going, 4 is also replicating to other data nodes. So whatever data block that is going to a particular node, it is not just staying there, it is also getting replicated to other data nodes. The reason for that, if one data node goes down, still the data is available for the other data node from. Okay, so name node still doesn't, so name node is the one that is coordinating, right? So whenever you have a request to get me 1, right, you might store 1 on the data node 1. Just because your data node 1 is lost, you don't lose your data. So even if data node is down, first one is down, still your name node can get the data from other data nodes where it is available. Okay, the blocks are replicated across multiple machines known as data nodes, and replication factor is threefold. I mean, it's the threefold is just a default. You could make it like 5-fold, 10-fold, 100-fold, depends on number of. In this example, we have 4 nodes, 4 data nodes, and it is threefold configurable, right? So depends on your number of nodes. So what threefold means, basically each block exists on three machines at least. If you see one is there on 3 machines, at least 3, and 2 is there on 3, like that. Okay, and the master node is basically keeping track of which blocks make up a file as a whole. Because when I query, I don't want to get 1 and 2 and 3 separately. But when I make whatever I gave you, the big block here, when I request to bring the same data, you should be able to go and find 1 2 3 4 wherever it is, and combine all that and give me back like a one big block of data. Okay, so that's the job name node is doing. Okay, so name node daemon must be running at all times, because that's the key, that's the main the manager of all the data nodes. So it has to be running all the times. Okay, and it holds all the metadata, and metadata holds it in the RAM. RAM means in memory, right? So not on the physical drive, on the physical hardware. The reason for why it maintains in the RAM, because it needs to be working very faster access. So in memory, if you need to get something from the hard disk, it'll take a longer time than in memory, right? So manages the file system namespace, and it manages without the name node there is no cluster. So if name node fails, it's basically a failure. That is one of the catch. You need to be very well aware. Of course, that doesn't mean people just don't maintain one name node, but you have to have a backup for name node, obviously. But name node is, from the architecture point of view, one name node is enough to maintain. But if name node go on, then that's a danger. So that's why you maintain architecturally. We maintain always name node also will have its own failover mechanism. Okay. So HDFS data node, it's a daemon running. Even if one goes down, the others will function. So you don't lose the data. Okay. Now coming to, this is what connecting to the nuts and bolts of MapReduce. What MapReduce means really, right? So this should be very clear actually. If somebody see this picture and don't get it, let me know. I'm very sure this is clear enough to make you understand. Let me walk through quickly. Basically, MapReduce is nothing but a model, like a programming model. It's originally created by Google and Yahoo. Okay, and why it is important? When you get some data set, a big data set, and you are splitting, right? You're splitting by key value pairs, and And then basically when you have a lot of key value pairs, you have to map them. Okay, and when you have the same key value pair 3 times coming, you could reduce them. You don't need to have 3 different key values, and all 3 can become like one key value pair, and the result will be, because you don't need to, the way the data process, first it try to identify what all the keywords it has, key and key value pairs, and then it will try to map them, and then try to reduce them. If it has any duplicates, like it'll avoid them. Okay, so that's how it will do, why it will do, and why it is important. So you'll see here, not here, on the next thing. Yeah, here it is. Look at this example. It's very common sense here, right? Somebody give an input called deer, bear, deer, bear, river, car, river, deer, car, bear. So somebody just give you a dump of words, right? I see like 9 words in this, and if you see manually with your eyes, I can tell there are 3 cars, there are 2 rivers, 2 bears, and 2 deers, right? Just because you're seeing with your own eyes. But for system, how does it know there are 3 cars and 2 rivers and 2 deers and 2 bears? And if you see the input and see the final result without seeing anything in between, right? In the final result, with my own eyes, I'm able to make that car 3, bear 2, deer 2, river 2, just by using my eyes, right? But when system is doing, if it has to find that result, okay, this is just 9 words. If I give you like million of words in a big text file, assume that in the Google search or somewhere, right? People searching for something, you know, all that comes as a big dump of like millions of words into a file, and somebody has to analyze that. What is in that, right? It is not that easy. So no, you cannot do with your own eyes manually, right? So it will be given to the system that programming this MapReduce model will start doing this way. First step is it will split the data. Okay, anything comes, it splits, right? Automatically. That's the MapReduce job. It splits the data. How it is splitting? If you see, it is splitting like there are 3 rows in that. It doesn't know what row has what words. It is splitting into 3 rows basically. First row went to like it basically created like a three paths, 3 splits, right? And first split has deer, bear, and river. And mapping, basically, what mapping is here doing? Basically, it is trying to sort it and count it. Basically, not sort it, count it. How many times deer word came in that split? 1 time. Bear comes 1. River comes 1. Right. Similarly, in the next time, car. Initially, you're not really doing any counting or totaling, right? You just simply each word you're counting and making a, okay, car I have 1, car I have 1, river I have 1, like that. So you're just mapping it. That's mapping. And then you are really shuffling and sorting. So okay, this is a standard example, word count process. Any Hadoop environment you take, first example a lot of people do is word count. So this is a very simple the fundamental thing that to be understood. Shuffling and sorting. So what are we doing now? We mapped everything. So now if you sort that, all the bear words come to one block, all the car words come to one block, all the deer words come to one block, all the river come to one block. Now once I shuffle and sort them, I can reduce them. I can say I don't need to maintain bear and bear 2 times. I can say bear 2 times, simply in one. Basically you're reducing it. You don't need to waste your storage for that, right? So you keep it, and you tag that as, okay, it has 2 times. And similarly, car, deer, like that. So at the end, your result is like that. So basically, this example clearly explain the need for MapReduce for any system to work like a human. Okay. So everyone understand this part? So stop me if you need any further clarification. This is a very fundamental thing. MapReduce is a heart of Hadoop system. Okay, so before we move forward, right? This is something I already talked this little bit, but you need to be aware of at a very high level. So it has master node, it has slave nodes. Basically, master node is the name node, and the slave nodes are the data nodes. And the purpose of name node is to track the job tracker, right? It submits the jobs to data nodes, and it keep tracking of the jobs, like which job successful, which job failed, and which jobs I have to again combine, which job I have to split, combine, shuffle, and all that. So basically, name node is managing all that job tracking. Slave nodes are task trackers. What that means? The data nodes are really not only keeping the data, the blocks of data, and also it is doing additional thing. It is taking the tasks from the name node. Okay, the task means like computation. So the data is there, and it's also taking the task. And let's say I get x plus y equal to g, I have to do, right? I take that task to the data node and try to do the task, and I need to keep track of the task. Then only I can give it back to name node and say, okay, my task is completed. Sometimes what will happen, let's say you have a big complex equation, like I have to do a plus b whole square, then divided by something like x plus y whole square, something like that, right? So then one block of computation will go to one task as one task. It is basically the task also split, right? So the first part is done by one task tracker, I mean one data node, and the other one is done by another data node. And but task tracker is going to finally understand, okay, part of this calculation is done here, part of this calculation is done here. So now I have to combine these two and send it back to job tracker. So that's how the complete job will be done. Other components. So this is something, it looks funny, but that's how it is, right? The captains of industry said it should work better this way, because everyone so far taking forward, but now we are pushing from backside.
Keshav garu.
Mm-hmm.
Yeah, this is Durga andi.
Japanese.
Can you explain again the master node and slave nodes?
Sure. Yeah. This one, right?
Yeah.
Yeah. So basically, when you build any Hadoop ecosystem, the cluster, basically the setup will be more like a number of nodes with cluster, right? Number of servers will be deployed, and you will have hundreds of nodes. In our case, actually, we have 1,000 in my current environment, 1,000 nodes, right? When I say 1,000 nodes, 1,000 data nodes, but we have a couple of name nodes. The name node, we are calling them name node and data node from the point of data node keeps the data, name node doesn't keep the data. It just maintain the metadata, which when I say metadata, what data piece is kept on what data node, it will register that. Okay, it's data about data. So that's first thing. Second thing, name node, also called master node, data node also called slave node. What that means, master node is the commander. It gives the commands to do the job for the slave nodes. Okay, so let's say I get a task saying that I got a job saying I have to do a complex equation, as I mentioned earlier, right? Some a plus b whole square, then multiply with x plus y whole square, right? And first of all, to do that multiplication, I have to do first a plus b whole square. On the other hand, I have to do x plus y whole square. Then I can multiply those two. It's like multiple tasks, right? The job tracker, the name node, basically master node is figuring out, it's giving the name node, basically breaking the tasks as three tasks there. One task is first part, second part, and the third part is multiplication of those two results, right? So it sends the three tasks as a three tasks for the data nodes, which will be managing their own task trackers. Each data node, when it receives the task, it is not only just doing the task using the data it has on the node. It is also tracking whether it is success or failure, or it needs additional data from other data nodes. It basically, sometimes you may not have all the data with your own data node, so it has to send that. It has to work with the task tracker will maintain that, okay, I don't have enough data in my data node, so some piece of information is there on the other data node. Can you bring me that to do my calculation? It will do that. And similarly, every task is, and also as I told, even tasks are duplicated. The same task is given for multiple data nodes, and same task being done by multiple nodes. Sometimes one data node failed to do the task, but other thing completed. Sometimes both are doing, but one thing came faster, one thing came slow. So as soon as the whatever is the first one completed, the other one automatically get killed and automatically get dissolved. And the first, whatever is completed first, it will send the task tracker will communicate back to name node, which is actually maintaining job tracker, and there it will tell, okay, my task is done. So that's how the communication happening between master node and slave nodes.
Yeah, and I got it.
Okay. Yeah. All right. So now we are jumping into some of the tools, right? Because everyone needs to be aware of, when we say Hadoop, we talked about HDFS, we talked about MapReduce. We understand what MapReduce means and how the master nodes, slave nodes works. Data nodes, and what is data node and what is name node and what is the function of each of that, what maintains job tracker, what maintains task tracker. So you need to be visualizing all that stuff in your mind, because that is exactly going to happen in the real environments. So if you have understanding of what is doing what, so you will be able to manage your system better. Okay, the tools here we're talking now, the most important tool and the most popular tool in any Hadoop environment is Hive. Okay, without Hive, I never seen any implementation without using Hive, and which is so popular. And again, Hive is the original version of Hive is it is going to use mostly MapReduce logic behind the scene. Okay, but the new version of Hive, which is called Hive 2 now, the second version of Hive, it uses something called MapReduce 2. The engine, the behind the scene MapReduce, it is called now. First one is MapReduce, and now it's called MapReduce 2. The difference between the MapReduce and MapReduce 2 is how the MapReduce job is happening is a little bit different now. It's like more distributed way of doing with an engine called ARN. ARN, that's another keyword on the Hadoop ecosystem. ARN, you won't use like a tool. ARN is like basically an execution engine where MapReduce is really happening. Okay, that execution engine, if MapReduce is running on ARN, that's called MapReduce 2, and that's what being used in Hive 2. Okay, so I'm just giving some context here because a lot of people, when you go, you will see in the tools also, like you have an option to use Hive or Hive 2. So Hive 2 always is preferable because it is more advanced and more the way it works is underlying. It could be, you may not see big difference as a developer, but architecturally how it is working, and it's more efficient. So Hive is an abstraction of on top of MapReduce, and it allows users to query data on Hadoop cluster without knowing any logic about what Java or MapReduce logic that you need to know. Okay, so Hive is like you can think of this like a SQL tool. Like people used to have Toad or SQL developer on the Oracle database side, right? You don't need to know how Oracle works. As long as you know how to use Toad, you can write some queries and it will go and get it from Oracle database or other databases. It will do the job for you, right? Something very similar. So you don't need to really know how Oracle actually bringing the data for you, how it is actually When you submit a query on a Toad or a SQL Developer tool for a Oracle database, behind the scene it actually do a lot of stuff, which if you really get into the technicalities, it actually split the job. Like whatever query you're submitting, it will split the job, and it will do a lot of parallel things behind the scene, and try to there will be something called optimizer also, right? Oracle engine has its own optimizer. What join is the best, it will decide that, and it will do accordingly. So there are a lot of stuff happens behind the scene. Similarly, on MapReduce, it's like a standard logic, the programming logic that happens, which is available by default on Hadoop cluster. You don't need to understand how that MapReduce works, or the some of the Java type of coding and underlying to make that happen. All you need to know is Hive tool and basic SQL commands. Hive supports pretty much like SQL type of commands. Most of the SQL works, but I would say most of the SQL, not complete ANSI SQL. ANSI SQL standards are superset of SQL, if you call it as a superset of SQL commands, and most of them will work as it is. But HiveQL, they call it as HiveQL here, right? This language has some limitations on some of the commands. That's why it's like, I would call it a subset of SQL, but I would say mostly it will work. A lot of people who have experience with Hive using, they will immediately know what works, what doesn't work, and that's where you will gain experience, right? But again, there is nothing to worry. As long as you are able to use regular SQL, you can always try using the similar SQL. If it doesn't work, then you can search it in a Google forums everywhere. People will have hundreds of forums that will tell you, oh, you know what, the self join doesn't work. So you try this other alternative workaround. One simple example, self join. In a SQL, regular SQL, you could do a self join. For example, if you want to find a relation between an employee and manager, right? Both are employees for a company, so both are in the same table. Both will have the records in the employee table, but on the employee record, you will also have another column that says manager column. That's where you will have that employee ID again as a manager. So if you want to find some query, you have to do a self join on the employee table 2 times, one as employee, one as a manager, to get the information. So that type of self joins doesn't work in HiveQL. Reason for that, again, it doesn't mean that you cannot do the job function, right? You still be able to do as a workaround. You can apply some where conditions. You can still rewrite your query in a different way. It may not be the best way of writing query in general terms, but you have a workaround, so nothing to worry. All right. So, but those things will come as you practice more on the SQL and the HiveQL language. So don't worry. And anything that it comes as some error or something, that you can always find a lot of information on the Google. If you search it, you'll find somebody might be already faced, and simply provide the workarounds for that. And yeah, that's what it is. So basically what happens when you create a HiveQL on the Hive interface, let's say just like a Toad. Imagine like you have a Toad and I have a Hive here, right? So when you put your query on the Hive environment, the query will break it down to MapReduce jobs behind the scene. In other words, if you have to do the same logic, you have to write all those MapReduce jobs on your own using Java, Python, things like that, right? But you really don't need to do, because you are very good, familiar with SQL, so you could easily write your HiveQL. This is basically to make it easier for developers, but behind the scene, it's still doing the same. It's creating MapReduce jobs, and it is working through whatever logic it has to go through. Okay, and those MapReduce jobs are submitted to job tracker and running on the cluster. All right, so this is basically, if you see Hive, basically it started from Facebook. That's who started a Hive. Facebook brought this concept, and this become very popular. I mean, because as you know, most of the IT, traditional systems, right? All of them using database for so long, and people are so much stuck with the SQL. And suddenly, if you ask somebody to come and write MapReduce jobs in only some Java or some other languages, right? So not everyone is familiar, especially people who are close to the data. So they are more familiar with SQL. So that's why they made it easier. So here it is, just a little. If you take a look how it works, simple high query, select stock product sum from this inner join on this condition. So basically, what it is doing, right? This is how it is happening. The Hive architecture. There is a name node that has job tracker. There are data nodes that has task trackers, and basically MapReduce jobs are running here. But you don't see any MapReduce jobs happening. When you really use Hive, behind the scene it is using one of this interface. Hive has its own command line interface. Directly you can run on Linux or whatever server we use for our Hadoop cluster. You can simply type it on command line Hive and run your Hive commands. There is a web interface that comes with like a Toad or some tool type of thing comes UI, or it can also go through JDBC, ODBC type of connections, and Metastore as well. Metastore means like Hive Metastore is there on the Hue and other UI tools. Okay. Yeah, I need to mention a couple of important points here. Impala. Hive, I told you Hive is so important, but it is meant for batch processing mostly. Okay. See, you will see a lot of these tools coming here, Hive, Impala, and Presto. A lot of things will come, Spark. A lot of things keep coming, these words, but you need to be aware of what is meant for what purpose. Okay, each one has a different purpose. If I have something like a ad hoc query that I need to run interactively more frequently, it doesn't make sense to use Hive. In those cases, if any interactive query that you run more frequently for some analysis, Hive is not the best thing because it's meant for batch processing. MapReduce is mostly batch processing, and that batch processing, when I say batch processing, you might understand like what type of batch processing. For example, you have a ETL Informatica, let's say in data warehouse somewhere, right? What it is doing every day night, there is a big batch job. It's trying to collect the data from its source systems and process it once in nightly and put it into data warehouse, right? So we used to work with Informatica or data stage or a lot of ETL tools, and that's called batch processing. So your query or your whatever that process you're running, it doesn't need to be like a interactive. It runs once a day or some schedule, and then it's not like an interactive. User will be waiting for that, right? It's happening on the back end, and it's not going to impact user. If it is supposed to, let's say if user running a query on the UI from from a web page or some SQL developer tools, if I run a query and if it is taking like 10 minutes, it's not coming and it's spinning the wheel, then they will feel frustrated. And that's the type of thing is not, that's called interactive querying. So for those scenarios, Hive is not good. So people, you can still use Hive, there's nothing wrong, but it is not the efficient way of using. Okay, Hive should be used for batch jobs, and Impala should be used for interactive queries. When I say interactive, I mean any ad hoc queries or analysis type of queries from the applications. So Impala is one of the powerful tool. It is actually developed by Cloudera, I believe, and but Impala is not available in all the Hadoop ecosystems. I mean, Impala is there as a from Apache Foundation, it is there, but it's adapted by Cloudera ecosystem, heavily used. But for example, Hortonworks don't use Impala. They use something called Taze, which is still depending on Hive 2, which I mentioned earlier. Though we know Hive is not good for interactive querying, Taze is using Hive to, in a distributed manner. Taze is another engine that helps. It will simulate distributed parallel processing. Okay, so all you need is, if MapReduce is slow because it's batch, but if you can do the MapReduce job in a parallel, like a multi-tasking, multi-threaded approach, it is not that bad. So that is what Taze engine is doing for Hortonworks. But that is good for some scenarios. So people still use Hive in case of Hortonworks. But if somebody using Cloudera, they don't have Taze engine. So they use Impala. So it's all adoption, right? So there are so many ways of using these tools from Apache Foundation. Cloudera adopted Impala, and it is exactly doing the similar thing. Impala is nothing but, it will still do the similar thing, but it works like a MPP, which is massively parallel processing system. If you see most of the data warehouse systems, like Netezza, Teradata, type of systems, they're all called MPP databases, right? So they have this massively parallel processing capabilities, and Impala is exactly built on the similar thought process. So it works something very similar to how MPP database engine works, but using the MapReduce jobs. Okay. So I mean, sorry, it's not using the MapReduce job. Impala is not definitely using a MapReduce job. Okay, it's totally done differently. That is the main difference. If it is a Taze, which is equivalent to Impala on Hortonworks environment, that will still work through MapReduce jobs, but it will create similar effect like MPP. Okay. And now, though I talked about Impala or Taze, those two are meant for, Impala meant for mostly Cloudera, and Taze meant for Hortonworks. But the most relevant thing that we need to talk about is Amazon EMR, because we are trying to learn the course using Amazon EMR as our tool set for the Hadoop ecosystem. So what Amazon EMR is using is a good question, right? They're not using Impala, they're not using Taze. They're using something called Presto. Okay, that's another something similar, different framework, but that's adapted by Amazon EMR. The reason for that, most of the stuff works very similar, but architecturally there are some fundamental difference in the behind the scene. But at the end of the day, it's all how you make it faster, your processing. Like if it is a MapReduce job, it's going to be slow a little bit, and it's meant for huge data processing in a batch mode. Okay, but if you have to run something like a quick and interactive query run, then it doesn't make sense to submit a MapReduce job and wait for that. So that's why Impala, Presto, Taze, and all these things came. Okay. All right. Yeah, I think I mentioned that also here. Again, just to quickly see here, if you want to see the difference in the architecture wise, how Impala really works. So if you see last time, Impala has its own, the way it works is different, just like a database. If you see Oracle or a lot of database engines, how it works, like MPP databases, this is how they work. It's exactly using the similar architecture. You submit something from SQL application or ODBC driver or something, it's going to create a query planner, and which will have a query coordinator, and underlying it have a query execution engine, and that execution engine will work with HDFS or HBase underlying, whatever behind the scenes storage. Okay, so it will create query planner with multiple coordinators and multiple query execution engines, and it can come back with results quickly. Okay. Yeah, here. So now, whatever is all the other things are for informational and knowledge purpose, but what we are really going to use in our scenario is Presto mostly. We are going to do Hive also, I'll come to that, okay? Because we have a need to use various tools in various scenarios throughout our course for some of the exercises. That's why you need to be familiar with what tools we are learning and what tool is relevant in what scenario. Then tomorrow when you go to any project as well, the same thing. You have to know what tool is suitable for what type of purpose. So here, this architecture is also very similar to, as you saw earlier, like it's going to be more like a push model where tasks coordinate with each other. And the good advantage in this one is it doesn't need to have any IO operations with disk. I mean, it will try to minimize IO operations. That's why it's faster. Okay. So basically, yeah, the explanation also given here. If you want to read out quickly once, it uses the push model where it runs multiple stages simultaneously to process the SQL query. In this way, Presto avoids increased latency caused by disk IO operations. The downside is, yes, that is in-memory processing. That's correct. The Presto is in-memory processing, so your fault tolerance is very little. So what that means, if your in-memory go beyond certain limits or whatever, if it cross the limits or something you lost, so your fault tolerance is very little, so you can't get it back. So like, let's say I submit something and it's doing in-memory processing, and if something you lost, whatever is the task, one of the tasks, that's very difficult to recover. So basically, I mean, that doesn't mean that you will not lose anything. It has to rerun everything again. So if you submit like one big task and it splits into like hundreds of tasks, and finally, for some reason, because you're working in memory, out of memory problem or something comes, and one task fail out of that 100, and now 99 things are completed, but because of that one task, you have to redo all your 100 tasks. That's a drawback. Okay. But again, it's good and bad. In memory doesn't mean it will always overflow and it will go out of memory, as long as you have enough capacity planned and maintained. But there is a chance because it's in memory. It has its own limit compared to the file system. If it is a file system, you don't need to worry in HDFS, because your space is like abundant, and you will be able to add on the fly very quickly compared to RAM. Okay. Some quick pros and cons here, because why you need to know the pros and cons, when to use, when to not use. Again, consider Presto is like a equivalent tool for Impala, okay, which is totally different from Hive. All right, now I am getting into, there are 2 or 3, I think. I have to stop at this point to start lab, but these 2 are very important. So let me take quickly 5 minutes and try to get them over. Then we can move on to lab. Okay. Why Scoop, right? Scoop, you might have heard this, very popular. Scoop is nothing but, it's like a ETL tool in Hadoop world. Okay, in how you do ETL in the Hadoop environment, basically use Scoop. Okay, Scoop is nothing but SQL plus Hadoop. Okay, so it's very easy, especially for the people who do EW, they use a Scoop lot. So this is how it works, right? If basically Scoop connects from any database source, and if you write a Scoop job, it collects the data, extract the data, and load it into HDFS file system. And similarly, any data is in the HDFS system, it can take it from there and put it into any database tables. It could be any database, Oracle, DB2, SQL Server, it could be anything. You just need to have that connection, that whatever JDBC connection or for the Scoop. Okay. HBase, most important to know. kind of we already touched this yesterday because we worked with Amazon DynamoDB even without knowing what is HBase. Okay, so HBase is basically, it's a kind of storage. It's a little different than HDFS. HDFS is file system, but HBase is like more of a key value pair storage. It's like a database, object database, the data stored as key value pairs. Okay, so this is a little different setup, but it's one important component of Hadoop ecosystem. And HBase is the native NoSQL database for Hadoop environment, the open source world. But when you come to Amazon, it's called Dynamo. When it comes to Facebook, it's called Cassandra. So similarly, MongoDB. There are a lot of other NoSQL databases that all use the same concept, HBase. Underlying, it's all key value pairs. Okay. That's basically, it's called column oriented model. So the data, I think I explained yesterday what is column oriented database means, how the row oriented versus column oriented yesterday I explained. So if you revise that's exactly, you'll get the idea how it maintains. Yeah, I think this is the one I showed yesterday. I jumped onto this yesterday to show you how you think rows into columns. Now you have to start thinking as rows as columns. Okay. So hopefully I don't need to spend more time there. That's the last slide. That's good. We are right on time, 10 o'clock. So I will give a couple of minutes here to start the lab. I don't think lab takes more than 30 minutes. We can finish still in the time. But if anyone want to have any questions or anything, that we can take a quick break here for 5 minutes while we start the lab. Is everything you're able to understand, follow this, what I'm telling, or please stop me. Okay, feel free to stop me whenever you feel like something you want to repeat, or don't hesitate to ask. All right, so let's jump on to our next exercise. Here it is, right? So actually I'm supposed to do DynamoDB today because we stopped at HBase. That's where I prefer to do that. But yesterday I kind of little messed up this because I don't have the first topic planned earlier, but which is important. Then I realized I thought that you will not be able to understand what AWS is, so I added that yesterday. So that's why I switched that. My lab, we completed the DynamoDB yesterday, but today let's take that AWS Lambda, okay, which we haven't heard anything about it, but we are doing exercise. The reason for that, that's one of the newest feature of AWS and most popular. It's kind of called more of a serverless architecture key component for AWS. Okay, and this will be, I mean, you might think why we need that for big data analytics program, but it's one of the important component, important feature that we should be able to leverage in a lot of exercise we are going to do when we start our Amazon EMR and other important things that we do in our big data analytics path. Okay, so for the introduction purpose, you need to know what Lambda and how it works, especially on AWS environment, because this whole and soul AWS function, the revolutionary function actually. So I don't have any slides or anything to explain what is Lambda, but we are straight going to hit on to the exercise, so you'll know what exactly it is. Now let's go back to your account. Amazon, where is that? Go back to your Amazon quick labs. So at this point, if any of you think you need to leave. Don't worry. If you want to do tomorrow morning or anytime before, but you have to definitely complete this exercise before you come to the class tomorrow, because I don't want you to get lag on any of these exercise. So that way you are up to speed on what we are learning, because if you don't do this today, tomorrow, for other class when we need to use lambda function, you may be a little confused what this is doing really. So that's why it's important to finish every lab we're doing along with the course. Okay. I mean, I did this earlier, but let me see if I can open it. But for you, you need to, how to do, right? You have to search for the introduction to AWS Lambda. And let me see if what is coming up for me. Okay, I think when you search for introduction to AWS Lambda, did you guys see that or no? Can someone confirm that?
Yeah, Keshav garu, we get that.
You got it right? Okay.
Yeah.
So again, this maybe, is it a cost actually? Let me double check, because I have already done. Is it free or is it asking any credits?
No, it's
Free.
free.
It's free, right? Very good. Yeah. Okay. So yeah, some of these basic things are free. Generally, they don't charge. So look for the content. So again, I want to give a, never miss some of these basic things here when you look through, because if you want to know what is lambda, you don't need to really learn separately. When you're doing exercise here, you can skip the first. These things are standard. Yeah, don't miss to read some of this content, because this is how, as you are doing the lab, you're also learning. That's important. If you're just doing the lab and finishing it and you don't know what it is, and later on if you need to use the lambda function for something else, then you will have no clue why you're using there. Okay, so when you get to do this exercise, try to know more about it before even you start your exercise. Like, it says like 30 minutes or 45 minutes need, but before you start, first go through this clearly and understand what it is asking and what you need to do. So here I can give a quick, it's a compute service that runs your code in response to events and automatically manage the compute response resources for you, and make it easy to build applications that respond quickly to new information. AWS Lambda starts running your code with milliseconds of an event, such as image upload, an app activity, website click, or output from a connected device. You can also use AWS Lambda to create new backend services where compute resources are automatically triggered. What this whole thing is telling you is, basically it is a service, compute service. When I say compute, it's basically like a function that runs based on some event. Let's say I put some file on Amazon S3 bucket, which is or on HDFS somewhere, right? As soon as a file comes into my file system, or HDFS or Amazon S3 or anywhere in our environment, if I see a file every day, let's say every day a file command through FTP or something comes and put it on my system. As soon as a file comes, I want to trigger some process, and I want to pick up that file and I want to process that and put the data into HDFS file system or S3 bucket, whatever, right? So those things can be automated using Lambda function. So it is very handy and very useful, especially for making it like, basically you can write a small piece of code. It could be anything, Python, Java, or I think even a Unix shell script, or any type of code, basically small piece of code that could execute automatically when something happened, some event happened. Okay, and the biggest thing that they didn't mention here, what the specialty of Lambda is, Lambda doesn't use any infrastructure. You don't need to have infrastructure to run your Lambda function. You don't need to have, let's say you don't have any servers, no HDFS, no Hadoop or nothing. You just come to AWS website and you don't have any server for you, your own, but you want to do some function. Let's say you write some code, nice code in Java saying word count. If I get 100, 100 words in a file, in a text file, I want to use that file, and you write some Java program and say I want to count how many words in this file, right? It's just a Java code. That Java code, to run the Java code, if it is your own, if they assume that there is no Amazon AWS, what would you do? You have to buy a computer and you have to put all your Java, JDK, all the installation setup, and then you have to write your code, and then you have to compile your program, and then you run the Java program. Then it will do that computation for you to count your number of words in the file, right? Now I don't need to have anything. I go to AWS. It's kind of a free service. In fact, it actually, Lambda allows up to certain millions of computations. It will do free. Only after some limit they will start charging. So anyone have AWS account can use this service free. If you write some Java code or Python or whatever, you don't need to really have any server or EC2 instance or spend money on your infrastructure. You simply give that code and it will work. So it's basically serverless architecture. So this Lambda came as part of the serverless architecture. You don't need to have servers to do some computation. AWS allows. Okay, so try to use that. Now Amazon S3, everyone know that it is a simple storage service that Amazon, the pillar of Amazon AWS storage. It's a highly scalable object storage. And CloudWatch. Why we are talking about all this while doing this exercise? In this exercise, I think they use all these three: AWS Lambda, Amazon S3, CloudWatch. The relation between all these three, basically AWS Lambda function, whatever that code, is going to trigger based on the event. The event will be, a file will be placed on Amazon S3 bucket. As soon as a file, we put a file, let's say I upload a file into Amazon S3. So immediately a trigger will happen and AWS Lambda function will execute. And that function, basically how this will happen, Amazon CloudWatch is a monitoring service. It will be keep watching and trigger the things whenever there is it will basically set alarms, like whenever there is a file, there is a file came to S3, and that will give you a trigger and it will do the required function. Okay, that's how this exercise is. So without any delay, I think you get started. Hopefully you'll be able to spend some time. It says 45 minutes, but I don't think it will take that much time. Get started, and I'll stand by here and see if you guys have any issues. I can help you. So since I already finished, I'm not doing again, but you guys can go ahead and do. There is again, this is also a very basic one. I don't think there will be any. I don't think you'll stuck with anything specially. So go ahead and open. So I'll keep myself on mute, and I will wait for you guys to finish. And if anyone has questions, keep just shout at me, and I'll unmute and talk. Or let me do one thing. Let me make one of you, whoever is doing, on your screen. You can share the screen. So if anyone has any problem, that you can look at that. But again, nobody should have any issues on this. If you want to share, you can share. Otherwise, you feel free to do on your own desktop. That's fine. Because I can also do, but I don't want to start now because it will take 45 minutes. I mean, follow the instructions first time. Okay, don't forget the technique I mentioned. First time, whenever you are doing any exercise, first time, please follow the instructions carefully and do step by step. Even if it takes extra time and one more iteration doesn't matter. Definitely do first time completely understanding the instructions and why you're doing and what you're doing. And if you still have time next day, or or in the coming weekend, or whenever you have some free time, you try to do the same exercise that time without seeing any instructions, because then you will know how much you understand what you need to do in a real scenario. Okay. So I think tomorrow will be the main start point for us, because the first two sessions really are essentials that I would like to um, brush up for you, because that's something a lot of people, some people might know, but I seen that a lot of people don't have the complete understanding on these concepts. But once you have that, that's when really we start looking at what all the big data storage solutions available on Amazon platform, and how basically we get into Amazon EMR solution particularly. Okay, from there, actually, once we get introduced to that, then we will start, there are a lot of stuff to go through. That's when our journey starts really. I'll also keep the chat open here in case somebody want to chat anything, so feel free to chat there. Balu, is Chandu doing, or Chandu is not there?
He is not doing.
He's not doing. Okay, okay. But ask him to make sure he'll follow this, and maybe if he
Yes.
already did, it's good. But definitely ask him to do also.
Okay.
For you, I think you already done this. I believe, right? You already covered these things earlier.
Lab not there.
Okay. So what are you doing, Balu? Lab, you have the, I mean, it's a free account, right? So you're able to do that, right?
We do, but not morning time. Like I, I can do in the evening.
Okay, okay. No, 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 not now, but whenever in your free time, basically, because
Okay.
it may not take more than 30, 40 minutes generally. So whenever you have time, try to do that.
First time it will take.
Yeah, yeah.
థ్యాంక్స్ కేశవ్ గారు, డన్ అండి.
You completed? There is?
యా కంప్లీటెడ్.
Very good. Yeah. Okay. So no issues, right?
యా నో ఇష్యూస్.
Very good. Yeah. Okay. Yeah, it should be straightforward. There should not be any big problem. So yeah, I think just try to just be prepared and try to digest these, all these things that what we're talking. So there is some of this terminology like it looks like easier, but later on when you are into practice, you should know what to use, when to use, and all this. So yeah.
యా ఓకే అండి.
Okay.
థ్యాంక్స్ అండి.
Yeah, keep reading more as much as possible on the forums.
యా షూర్ అండి.
Okay. Yeah. All right. Good night.
గుడ్ నైట్.
Who else there? I think yeah, Monica, you're doing right. Kumar and Kishore also there. Yeah. Okay. Yeah. Let me know, guys, if you need any help or anything you stuck.
Oh, can you hear me now? I'm having trouble. Hello?
Yeah, I can hear Amma. Yeah.
అదే అంకుల్ నాకు ఇక్కడ లా log groups దగ్గర ట్రబుల్ వచ్చింది. It's saying that there was an error loading log streams.
వన్ సెకండ్ నీ స్క్రీన్ షేర్ చేయగలుగుతావా? నేను లెట్ మీ మేక్.
యాక్చువల్గా ఇందాక నేను ల్యాప్టాప్ నుంచి మాట్లాడి ట్రై చేస్తే మీకు వినిపించలేదు ఎవరికి, సో నేను మళ్ళీ సెల్ ఫోన్కి వచ్చేసాను.
ఓకే, యా, వినపట్లేదు ఇంతకు ముందు, ఇదే ఫస్ట్ టైము. Let me share controls. Can you share your screen now? You should see on the left side, you'll see an icon.
Yeah, 1 second. Actually, the work is on the laptop, so I'm going to go back to laptop and log in from there.
Okay.
Yeah.
Yeah, I'm seeing now. Yeah. Okay, what is it saying?
Sorry.
There was an error loading log streams. Please try again by refreshing this page. No log streams to show. ఇంతకు ముందు స్టెప్ ఏంటి? దీని ముందు స్టెప్ ఏంటి?
యాక్చువల్గా S3కి వెళ్ళి క్రియేట్ చేశాను లైక్ దే సెడ్, అండ్ దెన్ ఆఫ్టర్ దట్ ఐ కేమ్ బ్యాక్ టు లాంబ్డా ఆల్రెడీ. సో నేను ఒక ఫైల్ అప్లోడ్ చేయమని అడిగారు, సో ఐ అప్లోడెడ్ ఎ ఫైల్ అండ్ ఇట్స్ సెడ్ సమ్ ఇన్స్ట్రక్షన్స్.
Can you go back again to the S3 bucket? Go to services. Yeah, go to S3.
So create bucket.
Yeah, you already created or?
Yeah, I already have a bucket, so
Yeah.
here's the bucket, and then these two are the ones. So I'm gonna select this one. This is the standard one, and you already have this sample.txt uploaded, and then it tells me that to go back to Lambda, and then select S3 function.
Right.
Then monitoring. And then
yeah.
It was explaining about all these each one of the graphs. So, and then it told me to go to view logs in CloudWatch to see what's going to happen. So, so I wanted to see what was going on. And then this error like popped up.
No. Here you don't see anything because you don't have any log stream going on, because it's not live feed for you.
Okay. Got it.
The difference is in your S3 bucket.
Yeah.
If your S3 bucket is currently, you just put one file there, right?
Yeah.
So generally what people do is there is a continuous stream of log files coming there.
Okay.
So right now you don't have anything there, but that's okay. I mean, that error should not be any problem. They just asked you to go and use. Basically, intention is to show you how to check the watch. I mean that log.
Okay. I got it.
So yeah, that should not give any problem for you. You can move on to the next step. Yeah.
Okay. Thank you.
Yeah. Because they just want to let you know you can also view logs in the CloudWatch. Basically, that's what it is.
Okay.
So this is how you'll get exposure to explore the environment.
Okay, so that's the labs. That was okay.
That's
so
it.
it was great. Okay, great. Thank you.
Yeah. So yeah, I think. So how do you feel? Like you're able to get the points, or like?
Yeah, I understood everything. When at first when you were talking about MapReduce, the first diagram was confusing, but then when you gave an example, then I clearly understood about MapReduce.
Right. Yeah. Yeah, I try to keep as much as with examples. That way, it's easier to explain also, and people to understand. Yeah. Yeah.
Thank you.
Okay. So just keep doing the mostly if you follow this whole all the sessions, most of the basic stuff you will be able to find, and then you can enhance more from your own study as well. Okay.
Yeah. Thank you.
Yeah. All right. Good luck. Good night. Yeah.
Good night.
I think only you left, right? So yeah, let me.
Yeah, I'm the only one.
Yeah. That's fine. Yeah.
Thank you so much.
No problem. Yeah. All right. Take care. Good night.
Yeah.